Do you know what diffusion is? How is it related to the movement of atoms and molecules in substances? Where can diffusion be found in everyday life? You'll learn these questions and maybe a lot more in the following video, so let's get to it. Atoms are small particles of matter. We have said about atoms that we can combine them into molecules and that they are constantly moving randomly. This random movement of particles can be well observed in the phenomenon we call diffusion. When we say diffusion, we mean the spontaneous mixing of two substances. This is because every substance is made up of atoms or molecules, and these atoms and molecules are constantly and chaotically moving in the substance. So if we put two preferably liquid substances next to each other, then it will gradually happen that the atoms and molecules of one substance will move, and thus gradually get between the atoms of the other substance. Over time, the atoms and molecules spread out between each other in such a way that the two substances are mixed and a mixture is formed. Thus, diffusion is a process that takes some time and in which two substances are gradually mixed. This process is caused by the movement of molecules that takes place in liquid and gaseous substances. Diffusion, like Brownian motion, is indirect evidence that atoms and molecules in substances are constantly and randomly moving. It can even be shown that atoms and molecules in a substance with a higher temperature move faster, which we will show later in the video. Diffusion is said to be a spontaneous process. This means that we do not mix the substance content itself. With enough time, the substances will mix themselves without us having to help them. If we pour some other substance into a liquid, such as water, then gradually the movement of atoms and molecules will cause the atoms and molecules of another substance to gradually spread out in the water. Thus, over time, they gradually get between the water molecules, which eventually mixes them. Apart from liquids, diffusion can also be observed in gases. If we cook some food, then the smell of the food gradually spreads throughout the room or the entire household. The particles that cause the smell of food move in the same way as air particles move, gradually mixing with each other. There are many other examples of diffusion manifestations. For example, we will introduce tea infusion, where the substances contained in tea leaves get into water and then mix evenly in hot water. Here the question arises as to why we pour hot water over the tea. One of the reasons for this is that it helps the tea to brew. This is because diffusion occurs much faster in warmer substances. This is because at a higher temperature, the particles in the substance move faster. Faster movement means higher energy stored in the substance, which is reflected in higher temperature. Diffusion has the property that as the temperature increases, the time required for spontaneous mixing of two substances decreases. When moving faster, particles can mix much faster, which we will now show in the animation. In the animation we saw at the beginning of the video, we can see two substances. Each substance is represented by a different color, namely blue and red. These substances were separated from each other at the beginning, but gradually they begin to mix with each other and form a mixture as they move. This process takes some time, but eventually the two substances mix. Now we repeat this animation, but we speed up the random motion of the particles. By moving faster, the particles then move much farther with their motion. The mixing itself takes place much faster, despite the fact that it is again a random motion different from the previous animation, which depicted particles of substances with a lower temperature. However, we cannot see the movement of the particles themselves. So we will show the speed at which diffusion takes place on something larger that we can observe, namely the infusion of tea. We take two measuring containers. In our case, it will be two glasses, where we pour hot water from the kettle into the left glass, while cold water from the tap is already prepared in the glass on the right. Now carefully and slowly put the tea into both cylinders, and let the spontaneous movement of the particles infuse the tea. Diffusion always takes some time, that is, it does not manifest immediately. In the beginning, nothing happens at first, but gradually the color starts to change in the upper part of the glass with warm water, where our tea started to brew. Water in cold water always looks the same. If we hold on for some time, then we can notice a difference in the leaching. Diffusion of tea substances takes place significantly faster than in cold water. Diffusion takes place until the particles extracted from the tea leaf are evenly distributed over the entire volume of water. Similar to how tea is steeped in water, sugar or salt would dissolve in water. Expansion would occur faster in warmer water than in cold water. Now we start to see a slight reddish color even in a glass with colder water. This completes the experiment comparing diffusion in a warm and cold environment. When we let the infusion go on for some time, then it turned out like this. The water in hot water tea was colored more than in cold water tea. Therefore, the tea had to be steeped faster in warm water than in cold water. Finally, let's summarize what we learned in this video. We have said that diffusion is the spontaneous mixing of two substances, which takes place in such a way that atoms and molecules in both substances move. It takes some time to mix the two substances. If the temperature of the substances is higher, then the atoms and molecules move faster and thus manage to mix in less time. In the next video, we will talk about Brownian motion, how it differs from diffusion, and how they have a common connection with the movement of atoms. That's it for this video. If you liked the video, don't forget to like or subscribe. See you on the next video.